Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. So today we are going to discuss the continuation of the types of the graphs that we have discussed in the last session. So we are just continuing with the types of graphs and also the other concept, degree of a vertex, which is called in degree and out degree. So first let us continue with the types of graphs from the last session. So regular graph. So what is meant by regular graph is a graph is said to be regular if all the vertices of the graph have the same number of degree. So, which is nothing but here. So, same degree is nothing but, first of all, we need to understand what is meant by degree. So, degree is nothing but, let us suppose I have vertex 1 here. Let us suppose here I have one figure. So, where I have the vertices like 1, 2, 3, 4, 5. These are all the vertices. So, for this particular vertex 1, so how many number of edges are attached, and that number we can call it as it is a degree of the vertex 1. So here let us suppose degree of one vertex is equal to, so now this, for this vertex 1 here, this is one edge, this is another edge 2 and 3, 4. So altogether we have degree of 1 is equal to 4. So in the same way, if you go for the next vertex 2, so this is one edge 1, 2, 3, 4. So degree of 2 is equal to 4. In the same way, so we have another vertex 3 and we have edges like it is attached with how many edges is 1, 2, 3, 4. So now degree of 3 is equal to 4. So in the same way, degree of 4, the vertex 4. So this is 1, 2, 3, 4. So degree of 4 is equal to 4. So next we have 5. Degree of 5 is 1, 2, 3, 4. So degree of 5 is equal to 4. So now if you observe here, if all the vertices of the graph have the same degree, means what, how many vertices we have total here? 5 vertices. For all the 5 vertices, we have the same degree and the degree number is here 4. So let us suppose here if I have like this, then this particular graph we can call it as a regular graph. That is regular graph. So let us suppose here I'll take one more example. So let us verify whether it is a regular graph or not. So this is vertex V1, this is vertex V2, this is V3 and this is V. Now what is the vertex degree of V1? Degree of V1 is, so here 1 and this is 2. So degree of V1 is 2 and degree of V2. So this is 1, 2, 3 and degree of V3. So this is 1, 2 and degree of V4 is, so this is 1, 2, 3. So now if we observe here, the degree of vertex V1 is 2, V2 is 3. So V3 is 2, V4 is 3. So it means all the degree of the vertices are not same. Then I can say this is not a regular graph. But can I make it as a regular graph here? So if I draw like this here, so then it will become 1, 1, 2, 3. So degree of vertex V1 will become 3, V2 1, 2, 3. So it is 3, V3 1, 2, 3. Here it will become 3 and V4 1, 2, 3. So now if we observe, this is a regular graph. So I can make it as a regular graph also by having equal number of edges to each and every vertex. So now here, next we have complete graph. So a graph is called complete graph if every two vertices pair are joined by exactly one edge. So now what is the meaning here? So a graph is called complete. When I can say that particular graph is called complete, if every two vertices pair. So let us suppose this is V1 and this is V2 and they are joined by exactly one edge. Means there is no other option to draw from V2 V1. So that's why I can say here like this I should have for all the pair of vertices each and every one edge should be connected. So this is V3 for example. V1 to V3 also I have one. So V2 to V3 also I have one. Then I can say this is called complete graph. So now if you take the same figure here, So now if we observe, is this a complete graph? Let us take here the same figure. So now if you observe, from 1 to 2 I have only 1, and from 2 to 4 I have only one edge. So from 1 to 4 also I have only one edge. So 1 to 5 1, and 4 to 5 1, 3 to 5 1, 1 to 5, 1 to 3 also 1. So now if we observe, from 2 to 4 also 1, and 3 to 5 also 1. So this is also a complete graph. Why? Because here, so all the vertices are connected by only one edge. Now let us suppose here I am considering one more example. This is A, this is A, and this is B, this is C, and this is D. So let us suppose here, so like this I have. Now from A to B I have only one edge, B to C also one edge, and here C to D one edge, A to D one edge. But if we observe A to C, we have two edges. One is outside and the other one is inside. So then this one I cannot call it as a complete graph. Why? Because you should have only one edge from one vertex to another vertex. Next we have connected graph. So what is meant by connected graph here? A graph in which there is a path of edges between every pair of vertices in the graph. So there is a path from one vertex to another vertex. Like that, between every pair of vertices you should have. So here if you observe, vertex A, B, and this is C. Now this is D to E. So from C to D I have one path. So if I have C to D, then only I can able to go to D to E. Means, let us suppose I have the source is A. I want to move to E. So A to C, C to E, I cannot move it. Why? Because I don't have path from C to E. Now I can go to A to C. Then if I have path from C to D, then only it is possible to go to D to E, which is nothing but from source to destination is possible. Means if you want to move from source to destination, definitely you should have one path, and that is called, we can call it as connected graph. So not only from A to E, let us suppose I am taking B as a source and E as a destination. I want to move from B to E. So definitely B to C, and if there is no edge from C to D, I cannot move to E. Why? Because I don't have any other option here. So to go from B to E. So it is definitely I should have path from C to D. So if I have that path, then this graph is called connected graph. Otherwise it is not a connected, we can call it as, it is a disconnected graph. So this is all here disconnected. A graph in which the path of the edges does not always connect every vertex. So here if you observe, we have vertices A, B, C, D. This is one vertex. This is one graph. And next we have E, F, G, H. Now let us suppose my source is B and my destination is H. Now I want to move from B to H. So in which way I can go here is, from B to C I can go, from C to D I can go. Now if I have the path from D to F, then only it is possible to move to destination, that is from E to F to G and G to H. But here if you observe, there is no bridge here, there is no path here from vertex D to F. Not only from vertex D to F, even from A to E, C to G also I don't have any way. So as I find that here I don't have any path from one vertex to another vertex in these two graphs, it's not possible to move from source B to destination H. Let us suppose my source is B and my destination is A. Yes, I can go directly from B to A. And let us suppose my have source is B and destination is D. So B to C and C to D I can follow. But because I have the path here, the connectivity is there from source to destination. But as I don't have path from source to destination, that is B to H, that is called disconnected graph. So in the same way we have bipartite graph also. So what is meant by bipartite graph? A graph G, V comma E is said to be bipartite graph if its vertex set can be partitioned into two disjoint subsets. Let us suppose here V1 and V2, such that V1 union V2 is equal to V and V1 intersection V2 is equal to 5, and every edge of G, it should join a vertex V1 to vertex V2. So which is nothing but what we are doing here is, let us suppose I am representing this total graph with G of V comma E. So, and this G of V comma VE is said to be bipartite graph if its vertex set. Here vertex set is nothing but, here I have many number of vertices, but here what I am doing is I am just dividing that vertices into two types of vertices, which is nothing but red color vertices I am denoting with V1 and black color vertices I am denoting with V2. So let us suppose these are nothing but two disjoint subsets. So disjoint is nothing but what? If you combine this V1 and V2, you should get here. So if you give, you should not get any common values. Means these are types of vertices, these are also types of vertices under the same graph. So let us suppose these are the two disjoint subsets V1 and V2, such that if you apply union between V1 and V2, you should get all the vertices. And if you apply intersection between V1 and V2, you should not get any common vertex, which is nothing but 5. If these two conditions are satisfying, and every edge of G means what? This is one edge. It must and should here join the vertex V1 and vertex V2. Means whatever the edge you are drawing, that edge endpoints must be, out of the two endpoints, one endpoint must be the vertex V1 and another endpoint must be another vertex V2, which is in the same graph. So like this if you have, then we can say this is called bipartite graph. So here I am denoting, just for our understanding purpose, here I have just classified the vertices into few vertices V1 as red color and another vertices as black color, so that we can easily understand that whatever the edge we are getting from the vertex V1 to V2, definitely that edge has two endpoints, and those two endpoints, one from V1 and another one from V2. So in the same way we have other two figures also. So here also same thing, this is V1 and this is V2. V1 are red color nodes and V2 are black color nodes. And if you observe, we have many number of edges here. But whatever the edge we have, that edge endpoints must be one from V1, another one from V2. So like this here also, this is another edge and this is also another. Means you should not connect vertex to vertex in the same set. So this should not be entertained here. This should not be there. Then only we can say that this is called bipartite graph. In the same way here also we have another graph. So this is red and this is red, this is red. Now let us suppose one edge I am taking here. Let us suppose this is E1 and this edge is having, one is black and other one is red. Means yes, it is valid as per the definition. And this is one more, red and black. And this is one more, and this is also red and black. Means we have different type of vertex sets, whatever the edges we have in the figure. So this type of graphs, we can say that it is called bipartite graph. So next we also have complete bipartite graph. A bipartite graph G is equal to V comma E with partition V is equal to V1 comma V2 is said to be complete bipartite graph. So which is nothing but what here? So what we are doing is, so G is equal to, this graph G is equal to, we are taking V comma E. So with the partition V is equal to V1 V2, means I have partitioned this total graph of vertices into V1 and V2. And here I am saying this is a complete bipartite. How I can say this is a complete bipartite here? So V1 V2 is said to be complete. So let us suppose here the vertex A. So in V1 it should map with all other vertices in the graph V2. So that is nothing but here I will be drawing separately here. Let us see A, this is B, this is C and this is D. In here we have P, Q and this is R. Now I have partitioned this sets into vertex V1 and vertex V2. Now A should be mapping with P, Q and also R. Means whatever the vertex we have in the vertex V1, it should map with all other vertices in the V2. In the same way, B2P, B2Q, B2R. So C2P, C2Q, C2R. And D2P, D2Q and D2R. Like this, every vertex in the set V1 should be mapped with every other vertex in the vertex V2. So then we can say this is called complete bipartite graph. So in the same way, we have another graph which is called planar graph. A graph which can be drawn so that all of the edges of the graph do not cross each other. So what is meant by this one is, so a graph which can be drawn so that all of the edges of the graph. So here this is one graph here. So where I have the vertex A, this is vertex B, this is vertex C, and this is vertex D. So it can be drawn so that all of the edges of the graph, this is one edge, this is a edge, and these are all the edges. But it should not cross each other. So how many number of edges are you are drawing in the graph, it doesn't matter here. But whatever the edges you are drawing, those edges should not cross each other. Then only we can say that graph is called planar graph. So if you observe here, this is just crossing each other. Now if I can be able to make this graph without edges crossing, then I can say that is called planar graph. So here if you observe, this is A, this is B, C, D. Now from A to C I have. So A to C I am drawing back side. From the back end I am drawing. And from B to D I am drawing inside. Now here no edges crossing here. So this is called planar graph. And now if you observe here, so this is A, this is B, C. Now from here to, let us suppose this is I am taking it as D. A to D I am representing, D to B, D to C. So here no edges crossing here. So with this vertex only it is dividing to another vertices. So now I can say this is called a planar graph. Then what is meant by non-planar graph? A graph that is not a planar graph, in other words, we can say that a graph which cannot be drawn without at least one pair of its edges crossing. Means, so these graphs I can able to draw it without edges crossing. I mean, this is the original graph I can say, and this original graph I can able to draw it without edges crossing. That's why this graph I can call it as planar. In the same way, that original graph, if I cannot able to draw it without edges crossing, why? Because there are some graphs without crossing edges I cannot able to draw it, and those graphs we can call it as non-planar graph. So here if you observe, so we have like this is vertex A, B, C, D, E. Now here vertex A to D is there, here one edge is crossing. Okay, let us suppose I am removing that and I am drawing from back end A to D. Now also we have A to C. Okay, let us suppose I am drawing from back end here. So this is not there. But even though here, so if I am not drawing here, A to B, E to B is there. So and D to B is also there. Okay, this is I am drawing no edges crossing. But we have E to C also. So if I go from outside E to C, here it is crossing. If I go from here, again it is crossing here. So means I don't have any option without crossing the edges, I can able to draw the CC. So as I don't have any option to draw from E to C without edges crossing, and this particular graph is called non-planar graph. This is called non-planar graph. So in the same way we have wheel graph also. A wheel graph of order n is obtained by adding a single new vertex. So to each vertex of a cycle, graph of order n. So which is nothing but here, always you have to think here. So in the middle vertex we will not be counting, and it is obtained by adding. So that middle vertex we can call it as what? Hub vertex. And a wheel graph always will have n plus 1 vertices and 2n edges, which is obtained by adding a single new vertex to each vertex. So here if you observe, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have altogether total 8 plus 1 vertices we have in the middle, including the new one, that is middle one hub. And how many edges we have is 2 into 9 is equal to 18 edges you should have. So 1, 2, 3, 4, 5, 6, 7, and here we have 8, 9, 10, 11, 12, 13, 14, 15, 16. So and also we have here 16. So n value is what here? So n value is 8, right? So 2 into 8 is equal to total 16 we have. And here altogether vertices are n plus 1. but we are counting with only n vertices excluding the hub. Then you will get 2 into 8, 16 edges we have. So this is called wheel graph. Next we have degree of a vertex. So in the just before we have discussed about regular graph. So how to count how to find out the degree of a particular vertex. So if you want to find out the degree of the particular vertex, first we need to search out so that particular vertex is attaching to how many edges, and those number of edges we can call it as degree of the vertex. So degree of a vertex in an undirected graph is the number of edges incident with it. So number of edges incident with it means what? So let us suppose here vertex V1 and this is vertex V2. This is vertex V3. So now V1 to V2, V2 to V3, V1 to V3. Now V1 is incident with how many edges here? 2. That is called degree of V1. So, and even here, except that a loop which vertex contribute twice to the degree of that vertex, you have to count it. Now, the degree of the vertex V is always denoted by degree of V. So, if it is V1, degree of V1. Degree of V2 means here also again you will have 2. Degree of V3 also will have 2. So, here if you observe, we have another figure. So, this is V4 to V1, V1 to V2, V1 to V3. Now, if you observe, the degree of V1 is 1, 2, 3. So, this V1 is incident with 3 edges here. That's why degree of V1 is 3 here. And degree of V2 is only 1 here. So, why? Because this is V2, only it is incident with V1. And degree of V3 is also 1. And degree of V4 is also 1. So, this is like how you have to calculate the degree of the particular vertex. So, that particular vertex should be incident with how many number of edges. And out of these vertices, you can also calculate what are even vertices and what are odd degree vertices. Even and odd vertex. So if the vertex is even, if the degree of the vertex is even, then the particular vertex is even vertex. And if the degree of the vertex is odd, then that vertex is called odd degree. So now let us suppose here I have taken one figure A, B, C, D. First find out the degree of each and every vertex, and from that you have to check it out whether the particular vertex is even degree vertex or odd degree vertex. So A, B, C, D here I have written. Now for each vertex we are calculating the degree here. So A is there. So A is incident with how many edges here? 2. The degree of the vertex is 2, A. And B, the degree of the vertex B is 1, 2, 3. So this is 3 and this is 2. And the degree of the vertex C here, it is incident with 2 here, then I can write 2. And degree of the vertex here D is 1. Now out of this, so first one and third one are called even degree vertices and other two are called odd degree vertices. So this is like how you have to find out here the degree of the vertex. And in this degree, we also have in degree and out degree. How to calculate in degree and out degree? So now if you observe here, we are calculated only degree of the vertex, and also out of the degree vertex, we are saying that which one are in degree or even degree vertex and out degree vertices. This everything will be applicable only for undirected graph. But if we have directed graph, how to find out is there will be two concepts, that is called in degree and out degree. So in a digraph, so digraph is nothing but what? So a graph which have directions, which consists of directions. So in a digraph, the number of edges incident to a vertex is called in degree. The number of edges incident to a vertex and the number of edges incident from the vertex, which is nothing but incoming and outgoing. So that is called out degree. So the in degree of a vertex V in a graph is denoted by degree plus of G, which is nothing but positive. Out degree means it is going from that vertex, going out, which is nothing but, so one you are losing, which is nothing but degree negative of G. A loop at a vertex in a diagram, it is counted as one edge for both in degree and out degree of that vertex. Now let us suppose here I have one graph here. Those vertices names are A, B, C, D, G. Now for the vertex A, in degree is what here? So from the vertex A, one in degree is there and out degree is there. Why? Because this is incoming and this is outgoing. So 1 and 1. And from the vertex B, both are outgoing only, there is no one incoming. So we can say that in degree is 0 and out degree 2. And for the C here, both are incoming. So 2 in degree, out degree there is no. So, and for the vertex D here, one incoming and one outgoing. So 1 and 1. And for the vertex E, so one incoming, one outgoing. So 1 and 1. So like this, you need to find out for the directed graphs in degree and out degree. So in degree is nothing but which is coming towards that vertex. So out degree means which is going from the away from the vertex. And we also have isolated and pendant vertex. So a vertex which is not connected to any other vertex in the graph, then it is called isolated vertex. So let us suppose here I have one vertex, this is called 3, and I have here other vertices also which are connected by edges, that is 1, 2, 4. Now this particular vertex is not connecting to any other vertex in the graph. So which is nothing but this is called isolated vertex. So here 3 is called isolated vertex, and also we have pendant vertex. So the vertex of a graph with degree 1. So always the vertex should have only 1 degree. This is called pendant vertex. So here if you observe, what are pendant vertices? It is not mandatory that in a graph if all the vertices are having pendant, that is nothing but degree 1, that is only called pendant vertex. So if in a graph you can have few vertices with pendant degree, which is nothing but degree 1, and few vertices we can have degree more than 1 also. But only those vertices with the degree 1 we can call it as pendant vertex. Now V4, it is having only 1. V3 it is having 2 edges. So degree of V3 is 2, and degree of V2 is also 2, and V1 is having only 1. So V1 and V4 are only having degree 1. That's why they are called pendant vertices. So what we have discussed today in this session is the continuation of the types of the graphs that we have discussed from the last session, and also we have discussed what is degree of a vertex and what are in degree and out degree vertices, what are even and odd degree vertices. So how to find out this in degree and out degree for the graphs like directed graph, and how to find out the degree and even or odd degree vertices for the undirected graph. So by this today we'll end the session. Thank you.